Welcome to this captivating lesson on rectilinear propagation of light. By the end of this session, you will understand how light travels, how shadows and eclipses form, and how a pinhole camera works. Rectilinear propagation refers to the way light moves in a perfectly straight path. It does not bend or curve while moving through the same medium. This is why we draw light rays as straight arrows in diagrams. The concept helps us understand shadows and how images form. You'll see this clearly in a dark room with a small light source. This straight movement is a basic property of light. Let's take a look at some evidences to show light travels in a straight line. One strong evidence of rectilinear propagation is the formation of shadows. When light from a source hits an opaque object, it cannot pass through, and a shadow forms behind the object. A point source of light creates a sharp and uniform shadow, because the rays are straight and narrow. A broad light source forms two distinct shadow regions, the umbra and the penumbra. The umbra is the darkest part of the shadow where the light is completely blocked. The penumbra is a lighter region where only part of the light is blocked. This happens because different parts of the broad light source are partially visible from that area. You can see this clearly in the diagram, where the penumbra surrounds the central dark umbra. Another evidence of straight-line travel of light is eclipse formation. An eclipse is a shadow formed when one space body blocks light from another. This happens only when the Sun, Earth, and Moon are perfectly aligned. The eclipse is strong proof that light moves in straight lines. If light bent easily, shadows would not form sharply. A solar eclipse happens when the Moon moves directly between the Sun and the Earth. It blocks sunlight and casts a shadow onto parts of the Earth. This makes the day suddenly become dark in the affected region. Only places inside the Moon's shadow experience the eclipse. It clearly shows that light travels in a straight path from the Sun. Without straight line travel, the Moon's shadow would never reach the Earth. A lunar eclipse occurs when the Earth moves between the Sun and the Moon. In this alignment, the Earth blocks sunlight from reaching the Moon. As a result, the Moon enters the Earth's shadow and appears dark. Sometimes the Moon turns reddish. This is called a blood moon. This happens only when light travels in straight lines from the Sun. Again, the eclipse confirms the straight-line nature of light travel. The pinhole camera is a simple tool that proves how light travels in straight lines. It has a tiny hole in front and a screen placed at the back of a dark box. When light from an object enters through the hole, it forms an image inside. The hole acts like a narrow tunnel guiding light rays straight to the screen. If light did not move straight, no clear image would be formed. This device makes learning about light behavior fun and visual. The image formed inside a pinhole camera has three main features. First, it is real, meaning it can be seen on the screen. Second, it is inverted, upside down compared to the actual object. Finally, it may appear smaller or larger based on object distance. If the object is closer, the image is larger; farther, it becomes smaller. These image features again show light's straight line travel. The smaller the pinhole, the sharper the image. If the pinhole is too large, the light rays overlap and make the image blurry. The magnification of an image tells us how much larger or smaller the image is compared to the original object. We use the formula m equals hi divided by ho, where hi is the height of the image and ho is the height of the object. This can also be expressed as m equals v divided by u, where v is the image distance and u is the object distance. If m is greater than 1, the image is magnified. If m is less than 1, the image is reduced. A positive magnification means the image is upright, while a negative magnification indicates the image is inverted. Let's solve an example using these formulas. Let's take a look at our first example. The length of a pinhole camera is 12 centimeters. It is used to photograph an object 60 centimeters away from the hole and 80 centimeters high. Calculate the height of the image and magnification produced. From the question we are given object height as 80 centimeters. Object distance equals 60 centimeters. Image distance equals 12 centimeters. We are asked to find image height and magnification. Step 1. Calculate magnification. Magnification equals image distance over object distance, which is 12 over 60. That gives 0.2. Step 2. Using the formula, magnification equals image height over object height. Make image height subject of the formula. We have image height equal magnification times object height. Multiply magnification by object height, which is 0.2 times 80. That gives 16 centimeters. If you found this explanation on this video helpful, don't forget to like this video and subscribe to our channel for more physics concepts made simple. Drop a comment if you have any questions or want more examples. Thanks for watching. To deepen your understanding of any topic, explore our comprehensive resources, including revision notes, past questions, gamified quizzes, and workbooks. These tools are designed to help you master the concepts effectively and enjoyably.